So the diagram show the graph of f of x, where the function is defined by f of x equals to 3 plus 2 sine quarter x for x in between 0 and 2 pi inclusive. On the diagram above, sketch the graph of inverse fx. So for inverse fx, the graph for inverse fx, we just have to check. We just have to flip the x and y. Okay, so if we see here, the y is pi and around 3 over 2 pi. Okay, it exits a little bit. Okay, so we put that 2 first. So we use this 2 as our anchor. Okay, so after that we look at the x. Okay, the x is from 0 to 2 pi. Okay, so we can assume that the inverse the y inverse, okay, will be starting from 0 to 2 pi. So remember, we just have to flip the x and y. Okay, so now with that being said, so the graph will look something like this. Okay, we just have to flip, okay, the x and y. That is how you make a graph for the inverse. And when we are talking about the mirror line, then this is the mirror line. This is the y equals to x mirror line. Okay, so that would be A on the diagram. Sketch the graph. So remember, every time you sketch the graph, please draw the mirror line. Yeah, just to make sure. Okay, and then find the expression of inverse fx. Okay, now we just have to, as normal inverse, yeah, every inverse you have to replace x and y. Okay, so I will just replace y with x and x with y. That is equals to 3 minus x, and sine quarter y, that is 3 minus x divided by 2. Quarter y would be inverse sine of 3 minus x over 2. And finally, we have y equals to 4 inverse sine over 2. Okay, yeah, so that is the answer for B. Okay, for C, the diagram show blah 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 blah. Complete the sketch. Explain whether above the graph blah blah blah. Complete the sketch. Okay, we just have to input anything between negative half pi, because you see, for sine it's just like a mirror. So anything below 0, negative half, negative pi, will actually mirror what we see on the right hand side. So it is okay. Let's check for the maximum. This is around 3 over 2 pi. So around negative 2 pi, yeah, around here. Okay, so we just have to continue. Sorry, I'm using the stylus, so it won't be that precise. Okay. Yeah, and hence explain whether the function g has an inverse. Okay, if we see here, this is not a hyperbolic graph, so it is a one-to-one relationship input-output type, and yes, it does have in inverse. Okay, now describe fully a sequence of 3 transformations which can be combined to transform graph y equals to sine x for x be in between 0 and half pi to the graph y equals to f of x, making a clear order in which the transformation are applied. Okay, first of all, f of x, y sine x, the y f of x, 3 plus, okay, let me put this first so I won't get confused. 3 plus 2 sine quarter x. The original would be y equals to sine x. So if we see here, first of all, I can see we have a stretch at x here. Okay, so we are looking at stretch x. The first one would be stretch x with factor of 4. Remember, for stretch x, you have to flip. Let's say it is stated here is 1 over 4x. Okay, the factor is 4, so you have to flip. How about y? Okay, we also have a stretch of y here. The factor would be 2. You don't need to flip for y. Okay, we just have to flip for x only. And we have a translation. Okay, so translation would be the last. Translation with the vector 0, 3. Okay, meaning that it doesn't have y translation, it only have x translation. Sorry, it doesn't have x translation, it only have y translation. Okay, yeah, so 0x and 3y. Okay, so the final transformation first would be stretch x factor of 4. Remember to flip. And then stretch y factor of 2. You don't need to flip. And translation y. Okay, no translation x, only translation y. Okay, that is for